All right, marine science students who are at home for one reason or another, whether you are a distance learner or you're just quarantined for a couple days, I've got 6.3 here for you, major ocean environments. This is a pretty short lesson today. I will give you a heads up. There's a little snafu on the study guide. The first box is I don't understand what happened. I don't know. But the first box, the title is wrong, and so I'll walk you through where stuff is going to go today. But just please try to follow along, because there is a slight mistake with the boxes on the study guide for 6.3. So we're looking at major ocean environments today, and right here, right off the bat. We're putting this in the second box. You'll notice the second box, the category on it is broad categories of organisms. Let's put that there, please. Leave that first box blank for now. So 3 broad categories: nectin, benthos, and plankton. Our nectin are marine organisms who are strong enough to be able to swim to oppose the currents, meaning they can go where they want to go. They decide where they're going to be able to swim. The water is constantly moving. There's always some kind of current or wave and tide, and the water is always on the move. And these nectin are able to fight against that movement of the water. An example would be a sea turtle, shark, tuna. A lot of the typical stuff that we think, anything that you think of that can swim along, that's a nectin. Benthos are going to be your creatures who live at the bottom in what's called the benthic zone. You'll see on the study guide we have a whole category for that. But these benthos are things like crab, coral, different types of like slugs and sea cucumbers, the kind of thing that would primarily reside at the bottom, either directly on the surface or even within the sand a little bit. Just things that are going to be living at the bottom. And then we have our plankton, our drifters. They drift with the current. They are not able to swim with the current. They are at the will of the water. Wherever the water takes them, that's where they have to go, are unable to swim against it. These are going to be our phytoplankton and our zooplankton. We're going to see more about that in just a moment. So we've got an image here. Just to break it down for you again, our plankton, our little microscopic guys, we're going to talk about more on our next slide. They're floating along at the will of the water. They can't decide where they're going to go for themselves. And then we've got our nectin, our sea turtle, our squid, our shark, our dolphin, who are able to swim against the current. We would include the ray in that down here as well, even though he's towards the bottom. And then we've got the stuff that is on the bottom. We see the sea star here, and a number of different types of coral and things that are living at the bottom as our benthos. All right, I'm not writing anything off of this slide, but I want to mention it. So plankton are small microscopic organisms that are drifting or floating. This could be in the sea or in fresh water. It consists of what are called diatoms and protozoans. So they also can include small crustaceans, and then also can include things like larval stages of larger animals. So squid are a good example of this. The squid, they're in the larval stage. They are drifters. They're so tiny that they are not able to swim around themselves. But then as they progress through their life stages, they become big enough to be able to swim on their own. All right, now a little bit more about these plankton. We've got our phytoplankton and our zooplankton. Phytoplankton are a plant form of plankton, again, which means drifter. So these are plankton or drifters that perform photosynthesis. They are a major part of most of our marine ecosystems. It's the base of the food chain, incredibly important. And then we've got our zooplankton, Again, all of this is in bold. If you see places where you can kind of abbreviate or shorten it, please feel free by all means. So if phytoplankton is our plant form of plankton, then zooplankton, I know the zoo, like go to the zoo to see animals. Zooplankton is going to be the animal form of plankton. So these do not perform photosynthesis, and so instead they need to consume their energy, meaning they eat. They usually eat either phytoplankton or other even smaller zooplankton. Oh, I probably should have said, if you don't have room in that other box, this is where you can go ahead and be writing those two at the top. Sorry, I should have told you that before, my mistake. Phytoplankton and zooplankton, if you need to put them in the major marine environments, you can, and just scratch off that heading. We don't have anything to put into that heading. I'm probably a little too late on that, sorry. And then we have our benthic zone. This is an ecological region of a body of water that comprises the bottom, such as the ocean floor, the sediment surface, or the top of the sediment, but then also sublayers underneath a little bit as well. And then we already have this, but animals, organisms that live there are referred to as benthos. An image there, where you would have some things like crab and sea cucumber. Just showing the intertidal zone. Notice that is in bold. Let's get that down. So the intertidal zone is between high and low tide that is exposed at least once a day. And lots of organisms that rely on these intertidal zone ecosystems. And then still in the benthic zone, this would be the last slide for benthic zone. You've got your subtidal zone then. You had intertidal zone, which included the tide area as it's going up and down. The subtidal zone is going to be the area just below that, below where the lowest tide level is, and then all the way out to the edge of the continental shelf. So these are areas that are always submerged, but that are they're still along the continental shelf. So we're not particularly deep yet in this subtidal zone. Then we get to the deep sea, where we have our bathyral, and hadal zones that are beyond the shelf break. The shelf slopes down, you have continental shelf, continental slope, and then we've got our deep sea floor, our abyssal plains, and then other features that might be along the seafloor. Moving on to neritic zone. The neritic zone is the region of shallow water above the continental shelf. So we're not along the seafloor now, we're in the water itself, above the seafloor for the neritic zone. So up to 200 meters deep. This is above the shelf. Light is penetrating. This is an important fact. In the neritic zone, light is penetrating all the way to the seafloor. So that's before the slope, before we get into these deep sea regions. The neritic zone is always going to have light. Because of this, there's going to be a lot of life that is able to live there. It's the most productive ocean zone, supporting the vast majority of marine life to our knowledge. We got an image here, good coral reef system with a bunch of fish there, and our sea turtle. Notice the light coming through the water is part of why I stuck that image in there. This is going to be a neritic zone ecosystem. Then we have our pelagic zone. This is a part of the open sea or ocean comprising of the water column. In other words, all of the sea other than that is near the coast or near the sea floor. And you can go ahead and keep writing that in pelagic zone, and pause me if you need to. I'm going to show you this image. So the dark blue here, this is our benthic zone right near the sea floor, and then our our continental shelf. Here, there's really not much of a shelf here. But basically what the image is trying to show is we call this the water column. So you've got multiple different zones here within the pelagic zone. The pelagic zone can be broken up into all of these different zones that we will mention on our next slide. So it does not include the benthic zone or what would be the neritic zone, say if this area here had kept going and been underwater. I need to find a better picture for that next time, maybe. All right, for our pelagic zone, you've got the epipelagic, which is from the surface to about 100 to 200 meters. So this is going to be that surface layer of that water column. Plenty of sunlight available, lots of primary production, and lots of producers, and lots of phytoplankton, lots of plankton that are performing photosynthesis. Then you got your mesopelagic zone, is from the lower limit of where the epipelagic ends to about 1,000 meters. So there's reduced light here, very, very little light. There is some light, but very little. And then you get down into these others, the bathypelagic, abyssopelagic, and hedopelagic. These are deep sea zones where light does not penetrate. All right, and then there's two more images to mention to you real quick. Again, seeing them broken down here. And this image maybe does a little bit better of a job of giving us a neritic zone here above the shelf. It does not really specify our benthic zone here, which would be along the bottom, but it does break down our different pelagic zones for you. So there you have it. Major ocean environments. We're going to break down ecosystems into a lot more different categories later down the road, but those are our major marine environments. For our next lesson 6.4, we'll be looking at energy flow through an ecosystem. See you later. Have a good one.